Industrial processes waste enormous amounts of energy as heat. In many systems, that energy simply disappears into the atmosphere as hot exhaust gases, but engineers have found a way to recover it. What you're looking at is called a heat recovery steam generator, one of the most energy efficient recovery systems used in modern industry. By capturing waste heat and converting it into steam power, systems like this can push overall plant efficiencies from around 35% to well over 60%. So, how does this system actually work? The process begins at the feed water inlet. This water is recycled condensate, returning from the steam turbine after completing its first cycle. At this stage, the water is relatively cool at 35 to 40 degrees C. It first enters the Economiser section, which is the final heat exchanger inside the HRSG before the exhaust gases leave through the stack. Even here at the coldest end of the system, the exhaust gases are still very hot at around 150 degrees C. To recover this energy, the economizer captures it and uses it to preheat the incoming feed water. As the water flows through the tubes, its temperature rises. The preheated water now enters the steam drum at the top of the system. From here, the water flows downwards through the evaporator tubes. These tubes sit directly in the path of the hot exhaust gases, where the boiling begins. At this stage, the exhaust gases are sitting at the round about 300 to 400 degrees C. That intense heat transfers through the tube walls into the water. As the water absorbs energy, it begins to boil, creating a mixture of water and steam inside the tubes. That mixture naturally rises back into the steam drum, creating a continuous circulation loop. Inside the drum, the steam and water separate. The heavier liquid water falls back down to recirculate through the evaporator again. Meanwhile, the steam rises to the top of the drum. At this stage, the steam is now saturated steam. It's reached the boiling point for its pressure but still contains moisture. Before it can drive a turbine efficiently, it needs more energy. The steam now enters the hottest section of the entire HRSG, the superheater. This section sits closest to the exhaust gas inlet, where temperatures can reach 450 to 550 degrees C. Here, the steam passes through multiple banks of superheated tubes. With every pass, it absorbs more and more energy from the exhaust gases, and its temperature reaches far beyond the normal boiling point. Eventually, the steam transforms into superheated steam, where there's no liquid droplets remaining. This is critical as the water droplets can affect the efficiency of the turbine at high speed. By the time the steam leaves the superheater, it can reach up to temperatures of 550 degrees C at pressures above 100 bar. Now the steam is packed with energy, it's suitable to enter the steam turbine. The superheated steam is fired directly into the turbine at extremely high pressure. As the steam expands through the turbine stages, it forces the blades to spin at high speed. That rotating shaft is connected directly to a generator, which converts the mechanical rotation into electricity for the grid. But the cycle is still not finished. After leaving the turbine, the steam has lost much of its energy and pressure. It then enters a condenser, a large heat exchanger cooled using water or large air cooling systems. Inside the condenser, the remaining steam is cooled back to liquid water. The temperature drops back down to 35 to 40 degrees C, and once again the water is pumped back into the HRSG as feed water. The entire cycle repeats continuously over and over again. If you enjoyed this video, please remember to like, comment and subscribe.